Good. Okay, so the aim here is how do we graph the tangent and cotangent functions? So we are done for the most part with sine and cosine. And with that, we're going to backtrack to, graphing the other trig functions. So like tangent, cotangent, secant, and cosecant. Okay. All right. So with that being said, can someone read the do now for us? You can just unmute yourself.
The graph of the tangent is shown here. A. What is the period of the tangent graph? B. What do you notice about the graph of tangent as it approaches pi over 2 and negative pi over 2? What values does it approach?
All right. So thank you for that. All right. Did anyone answer part A? Like, what would you say the period of the tangent graph is? Like, in other words, how long does it take for tangent to complete one cycle?
I guess I would say pi, maybe.
Pi? Okay.
Yeah.
All right. And all right, Dorothy, you raise your hand.
Oh, I was going to say the same thing.
Pi. Okay. Can one of you explain why you think it's pi?
Well, I mean, if you look at the middle tangent, or like the middle line there, like it kind of starts at negative pi over 2 and then ends at pi over 2, if that makes sense.
Yep.
Like,
Yep.
I don't know.
Good. Yeah. So yeah, if you focus on this middle branch here, right? So as we can see, it from negative pi over 2 to pi over 2, it's like one branch, and then after pi over 2, it repeats, right? So we could say that the period is going to be just pi, right? So it's going to be negative pi over 2 to pi over 2, and the distance between that is pi, one full. Well, I guess I shouldn't say one full, but 180 degrees, right? So the period will be pi. I'll show the answers in just a bit, but yeah, so just keep that in mind. The period of tangent is pi. Anyone answer part B? What do you notice, like what values does tangent approach as it approaches, as it approaches pi over 2 and negative pi over 2, what are the y values? Anyone for that? Okay, all right, that's fine. So when it goes to pi over 2 from the left, it goes to positive infinity. Okay, so that's what it approaches. For negative pi over 2, if we focus on this branch, right, this middle branch, then as it approaches negative pi over 2, it'll go to negative infinity. Okay, but to be more specific, it'll approach pi over 2 from the left, right, the left side of the wall, or the asymptote, as we'll see. It approaches positive infinity. As it approaches negative pi over 2 from the right side, it goes to negative infinity. Okay, but as you notice, right, there are other branches of tangent. So it'll go on forever on the x-axis. So as it approaches negative pi over 2 from the left, then it'll go to positive infinity. So it depends on which side you're seeing it from. Dorothea?
Is that because tangent of pi over 2 and negative pi over 2 are undefined?
Perfect, yes. That's because they're undefined, yes. So yeah, tangent, as you remember, it's sine over cosine. So wherever cosine is equal to 0, that's where it'll be undefined because we're dividing by 0, right? So cosine pi over 2, cosine 90 degrees is 0, right? All right, very nice, very nice. Okay, so let's move on from there. I'll show you the answers. Yeah, so as you see here, right, part A, the period of tangent is pi. And for part B, tan x approaches infinity, positive infinity, as x approaches pi over 2 from the left. Okay, so here I have a smaller graph of it. So pi over 2 from the left, that's on this side, right? So this is from the left. Over here will be from the right. But as it approaches pi over 2 from the left, it goes to positive infinity. And then as tan x approaches negative infinity, sorry, as tan x approaches negative pi over 2 from the right, that's this side right here, it'll go to negative infinity. Okay. And then I also make a note here. These are called vertical asymptotes, which you might remember from algebra 2. And, they'll show up again in calculus. But yeah, I'll show you the definition in just a sec. All right, does anyone still need this? You can speak up or type. Okay, if not, then let me give you an overview of the rest of the lesson. So yeah, just some notes for tangent, cotangent, definition of vertical asymptote. And then next we're gonna graph the tan and cotangent functions and another set of notes and then the classwork. All right, so with that said, let me get to the notes. All right, here it is. All right, can someone read this first part right here?
Properties of tangent and cotangent. The functions tangent and cotangent have a period pi. Tangent of x plus pi equals tangent x. Cotangent of x plus pi equals cotangent x.
All right, thank you for that. So yeah, as we just said, right, tangent and cotangent, or in the do now we only said tangent, but tangent has a period of pi, and likewise cotangent has a period of pi. If we look at the graph of cotangent, we'll see that it also repeats after a distance of pi, right? And if you remember, right, sine and cosine, those functions have a period of 2 pi. All right, so for sine and cosine, this would read sine parentheses x plus 2 pi equals sine x. All right, the y value you get at tan x is equal to the y value you get if you add pi to the x coordinate. And same thing for cotangent. All right, any volunteers to read this definition here?
The line x equals a is a vertical asymptote of the function y equals f of x if y approaches positive or negative infinity as x approaches a from the right or left. Tangent has vertical asymptotes at x equals pi over 2 and x equals negative pi over 2, and cotangent has vertical asymptotes at x equals n pi, where n is an integer.
All right, thank you for that. So a couple things I want to mention here. One is this terminology from the right or left. This is terminology you're going to see again in calculus when you talk about limits, which is the first unit in calculus. Okay, but yeah, you'll see that as x approaches a from the right or left, they'll have that wording in that unit. And for tangent, so tangent has vertical asymptotes at x equals pi over 2 and negative pi over 2. So the way I'll remember that is just remember the identities, right? So tangent is sine over cosine, right? And wherever cosine is 0, that's where there will be a vertical asymptote, right? Because that's where it's undefined. Cotangent is cosine over sine, right? So wherever sine is undefined, namely at multiples of pi, then cotangent will have a vertical asymptote. Dorothy?
Is the graph of cotangent like a reflection of the tangent graph over the line y equals x?
So let me be careful in saying, so the line y equals x, that would mean they're inverses of each other, which No, yeah, that would not be the case because the inverse of tangent would be arctan, right? Tan to negative first power. They kind of look like reflections of each other, but well, yeah, they're not inverses of each other. Sure, like they're reciprocals of each other, but they're not like inverses in the sense that like tangent composed with cotangent does not equal x. Right?
Oh, okay.
Yeah. All right. Does anyone still need these notes? You can speak up or type in the chat. Okay, so I'm gonna move on. Oh, is it? Okay. All right, someone needs it. Yeah, no problem. Just let me know when you're done. Oh, and yeah, just a FYI, we're gonna be starting earlier this week. So for those of you who came in later, it's fine. We're still getting used to it, but as I said on Google Classroom, we're gonna start 5 minutes earlier. So starting this week, we'll start at 1:25. Okay, so 1:25 to 1:50 will be our new starting time. Normally it's 1:30, but yeah, so we have 5 minutes of extra instruction every day. Okay. All right, so if no one else needs it, then move on to the graphs. Okay, so we're gonna graph tangent and cotangent, right? Just the basic graphs. I'm gonna move up for that. So I'll have these questions here in the notes. Yeah, all right, so we're gonna graph both, okay? So as I did with the sine and cosine graphs, we construct a table. One thing to note here is instead of 0 to 2 pi for sine and cosine, tangent, we're going to go from negative pi over 2 to pi over 2. Reason for that being is that's where the asymptotes are. Okay, so that's just to get like a full view of the tangent graph. So negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2 are going to be your x coordinates. And then at negative pi over 2, it's going to be negative infinity. At positive pi over 2, it's positive infinity. Negative pi over 4, it's negative 1. At 0, it's 0. Tan pi over 4, it's 1. Okay. And then from there, you can graph. Okay, so this is the graph from the old textbook that we will normally use in class. So just this middle branch is what you have to take into account. So 0, 0 is right here. Pi over 4, 1 is here. Then negative pi over 4, negative 1 is here. And then we have the two asymptotes on the left and right at negative pi over 2 and pi over 2. Okay, so this middle branch is what I would draw in your notes. Okay, does anyone still need this? The solution here or the graph? No? Okay. All right, I'm gonna move on then. All right, here's the graph for cotangent. So cotangent, it's gonna be a different set of x coordinates. And remember, this is gonna be dependent on where the asymptotes are. All right, so the asymptotes of cotangent, they occur at 0 and pi, okay? So yeah, cotangent of 0 is undefined. It'll be positive infinity. Cotangent of pi is negative infinity. And then at pi over 4 and 3 pi over 4, it's 1, negative 1. At pi over 2, it's 0. Okay, so as you can see here from this middle, yeah, so this is the branch that we're graphing. And as you can see, it goes down, right? So tangent, it ascends, right? Cotangent is a descending graph. So it'll go from left to right, it goes from increasing to decreasing. Or it's a decreasing graph overall, but yeah, it'll decrease. So yeah, the values there are pi over 2, 0 in the middle, and then you have 0 and pi, those are the asymptotes. And then at pi over 4 and 3 pi over 4, you have 1 and negative 1 respectively. And this branch that I indicated here in blue is the branch that you should graph. And yeah, so if this seems unfamiliar, it should, right? Because normally we don't graph tangent and cotangent, and I don't believe it's in the Algebra 2 curriculum. So this might be your first time seeing these graphs, but just something to get used to. Yeah, so as you can see, like the x coordinates are different from sine and cosine. Right. Terry?
Sorry. For the regular like cotangent graph, does it sort of do like multiple different like I guess lines like the way it's shown on the graph?
By lines, you mean the lines in blue?
No, like yeah, I guess like how it makes different like periods over that certain amount of time. Like it repeats the pattern, if that makes sense.
Yeah, so I think you're talking about the pink lines, right? The curves.
Yeah, yeah.
Okay, yeah. So yeah, if you graph cotangent, then it'll just like how sine and cosine repeat, right? After 2 pi, cotangent and tangent repeat after pi, right? So this branch will repeat, if you keep going from the left to right. Okay. Okay. Does anyone still need this? You can raise your hand, or sorry, not raise your hand. You can speak up or type in the chat. No? Okay, I'm gonna move on then. All right, one more set of notes and then we'll get to the classwork. Right here, okay. All right, can someone read this part, or these notes, I mean?
Tangent and cotangent curves. The functions y equals a tan kx and y equals a cotangent kx if k is greater than 0 have period pi over k. To graph one period of y equals a tan kx, an appropriate interval is negative pi over 2k, comma pi over 2k. To graph one period of y equals a cotangent kx, an appropriate interval is 0 pi over k.
All right, thank you for that. So yeah, this is just speaking to if we were to change the period, right? So like if we had a coefficient of x that's not equal to 1, then we change the period, right? Just like we did with sine and cosine. And then here for the a, that's the vertical stretch or shrink, right? Depending on if it's greater than 1 or less than 1. So I don't want to say amplitude because technically tangent and cotangent don't have amplitudes, right? Because they go on to positive and negative infinity. But that would be the vertical stretch or shrink, right? That's what you multiply the y values by. Okay, and the period is going to be pi over that coefficient k. For this bullet point, it's negative pi over 2. So negative pi over 2 to pi over 2 is what we graphed in the example that we did earlier. right? And then if you have a change in period, then you divide that by k, right? For cotangent, we graph from 0 to pi, right? And then if you have a change in period, then you divide by k. Okay, does anyone still need this? No? Okay, gonna move on then. Okay, so for the last thing I wanted to do is I just wanted to show you one of the classwork questions. So yeah, the classwork please submit it by tonight. So let me go over question 3. Well, question 4 is actually our due now for tomorrow. So, but we'll go over that again. Well, actually, yeah, let me go over question 4 because it's the most difficult one. So question 4, we had y equals 2 cotangent parentheses 3x minus pi over 2. So as we did with sine and cosine, we factor out 3, right? So we get 2 cotangent 3 of x minus pi over 6. Period is going to be pi divided by this number here, 3. Phase shift, as you can see here, is pi over 6. Okay. All right, so the x coordinates that we normally have for cotangent are from 0 to pi, right? And then from here, taking into account the change in the period, we divide everything by 3. So we're going to get 0, pi over 12, pi over 6, 3 pi over 12, and pi over 3. Next, we apply the phase shift. So we're going to add pi over 6 to everything. So we get pi over 6, 3 pi over 12. And the way you do that is pi over 6, if you multiply top and bottom by 2, you get 2 pi over 12. So 2 pi over 12 plus pi over 12 is 3 pi over 12. Next, we have pi over 6 plus pi over 6, which is 2 pi over 6. After that, it's 3 pi over 12 plus pi over 6. Right, pi over 6 is 2 pi over 12. Right, 2 pi over 12 plus this is 5 pi over 12. And lastly, we have pi over 3 plus pi over 6. Pi over 3, we can rewrite that as 2 pi over 6. So 2 pi over 6 plus pi over 6, the phase shift is 3 pi over 6. Okay, so these are the x coordinates that we're going to plot. And for the y coordinates, remember cotangent is descending, so it'll be from positive to negative infinity. So at positive, 1, 0, negative 1, negative infinity. There is a vertical stretch by a factor of 2. So we multiply everything by 2. We get positive infinity, 2, 0, negative 2, negative infinity. And these are the y coordinates we plot. Okay. So as you can see here, well, this is another graph from the textbook. We're going to graph this branch here. So we start at pi over 6. We end at pi over 2. That'll be this one right here. Okay. So pi over 6 and pi over 2, there are asymptotes. And then at 2 pi over 6 or pi over 3, there's a y coordinate of 0. At 3 pi over 12, it's 2. So that will be this here. And then 5 pi over 12, it's negative 2. That's here. Okay. And then, yeah, this is the branch that you want right here. Okay. So yeah, just a couple reminders. We're going to start meeting from starting at 125. Okay. This is, if you're watching this on YouTube, by the way, later on, this is for 7th period only. But yeah, starting this week, we are meeting 5 minutes earlier. And so yeah, just keep that in mind. And please submit the classwork by midnight tonight. We'll go over the classwork and the homework tomorrow in class. Okay. But yeah, if you're done with this, then you're free to go, and I'll see you all tomorrow. Take care.
Bye. Thank you.
Thank you.
All right, you're welcome. Take care. Have a nice
Have
day.
a good day.